The signal is weak. Try channel 4. I have it now. Stand by for message.
Blip 7R, bearing 040.
Confirmed. Steady plot.
January 1944. A storm rages over the Solomon Islands. Rain lashes against the jungle canopy, turning the narrow trails into rivers of mud. Lightning flashes reveal the silhouettes of Japanese technicians hunched over radio equipment in a makeshift coastal outpost. They adjust dials, scribble notes, their faces tense but confident, unaware that the night sky above is silently betraying them. Far across the waves, in a hidden Allied radar station, a faint glow illuminates the faces of American operators. Screens flicker with erratic blips, signals dancing through the storm. Each pulse slices invisibly through sheets of rain, revealing ships, planes, movements that should have remained hidden. The technicians below, focused on their instruments, have no idea that every motion, every calculation is being watched. Thunder shakes the hills. The wind howls, carrying the scent of salt and wet earth. And yet, despite the tempest, the radar pulses pierce the chaos, invisible yet relentless. Somewhere between storm and signal, between fear and discovery, history is being quietly rewritten. Every action, every decision that night will ripple forward, changing not just the course of battle, but the understanding of warfare itself. The storm, relentless and indifferent, becomes the stage for a silent duel between technology and human expectation. By the early 1940s, radar had moved from theoretical curiosity to a decisive weapon of war. The British had pioneered early warning systems along their coasts, and the Americans, observing the growing threat of Japan across the Pacific, accelerated their own radar programs. The technology was crude by modern standards, bulky, temperamental, and sensitive to weather, yet it offered a glimpse of the invisible. It could detect aircraft hundreds of miles away, track ships in the open ocean, and provide commanders with a level of situational awareness previously unimaginable. In the sprawling Pacific theater, the Allies faced an immense challenge. Island chains stretched over thousands of miles, from the Marshalls to the Solomons, forming a labyrinth that Japanese forces used to conceal ships and aircraft. Traditional reconnaissance, reliant on scouts and visual observation, was slow, dangerous, and often futile. Storms, dense jungle, and nightfall obscured movement, giving the Japanese a false sense of security. Yet radar, though still in its infancy, promised to pierce the darkness. By 1943, the United States had deployed early warning stations on key islands. Operators were trained to interpret the faintest blips on cathode ray screens, translating them into precise positions. Engineers worked tirelessly, testing pulse frequencies, adjusting antennas, and calibrating equipment to function in tropical storms. These stations were often rudimentary, tents and wooden shacks perched atop ridges, vulnerable to wind, rain, and enemy observation. Still, their impact was growing. Radar was no longer merely an experimental tool. It was a force multiplier, giving the Allies the ability to anticipate enemy moves with an eerie precision. On board naval vessels, the technology advanced further. The Navy fitted destroyers, cruisers, and aircraft carriers with radar sets capable of detecting aircraft over the horizon, even in torrential rain. Airborne radar, mounted on patrol planes, extended the reach of these networks, creating a web of detection across the Pacific. Every pulse, every sweep of the screen became a thread in a larger fabric of intelligence. Commanders began to see possibilities that had been inconceivable just a year earlier. intercepting enemy fleets before they could strike, directing fighters through storms, and laying ambushes with surgical accuracy. The Japanese, meanwhile, had invested heavily in radar development but faced constraints. Industrial limitations, material shortages, and strategic priorities meant their systems were fewer and often less reliable. Many Japanese coastal stations relied on optical instruments, visual observers, and radio communications. During storms, their warnings became delayed, fragmented, and sometimes catastrophic. They trusted the storm as cover, unaware that Allied technology was slowly eroding that advantage. By the time American radar pulses first cut through the Pacific storms, the battlefield had already begun to change. What had been a theater dominated by uncertainty and concealment was slowly becoming transparent to those who could interpret the signals. Every stormy night, every squall-laden horizon presented a duel between human expectation and technological reality. And on the other side, Japanese technicians, confident in their concealment, remained oblivious to the invisible eyes tracking their every movement. The tension between expectation and observation, between human skill and machine precision, set the stage for the events that would astonish the Japanese and reshape the Pacific War. Across the Pacific, Japanese forces prided themselves on discipline, precision, and ingenuity. Their technicians and observers were trained to detect threats through experience, visual observation, and radio communication. Coastal stations relied heavily on lookouts, scanning the horizon, signal lamps, and early radio intercepts. For decades, such methods had been sufficient. The open ocean provided vast spaces where fleets could maneuver largely unseen, and dense storms often acted as shields against discovery. By 1943, Japan's defensive network stretched across hundreds of islands, from the Marshalls to the Solomons. Coastal radar stations existed, but they were fewer in number and technologically constrained compared to their Allied counterparts. Material shortages, production bottlenecks, and a focus on offensive operations limited their effectiveness. Japanese forces often overestimated the security that weather could provide. Heavy rain, low clouds, and nightfall were considered natural barriers. Commanders assumed that stormy conditions rendered Allied detection almost impossible. Technicians maintained constant vigilance in harsh conditions. During typhoons and monsoon rains, they climbed observation towers, adjusted antennae, and calibrated instruments. Sweat and rain mixed on their foreheads as they peered through binoculars, scribbled charts, and radioed warnings along the chain of command. Their confidence was rooted in tradition and experience. A storm was an ally. A sudden radar blip on a cathode ray tube was, in their minds, still something that only human eyes could reliably see. Japanese air and naval strategy further amplified this reliance on natural concealment. Aircraft approached targets at low altitudes, hugging cloud layers, while ships navigated through narrow straits under cover of darkness. Tactical innovation emphasized deception and stealth. Yet, each move carried risk. Allied radar operators, trained to read faint echoes through storm interference, began noticing patterns that Japanese planners had assumed invisible. The storm that Japanese technicians trusted became a filter through which Allied technology could see them more clearly than they could see the Allies. The psychological component was significant. Technicians prided themselves on their ability to anticipate enemy movements, to predict where and when a strike might occur. They relied on human intuition, experience, and calculated observation. Yet radar did not operate by intuition. It operated by physics, sending pulses through rain, clouds, and darkness, bouncing them off metal hulls and wings. The Japanese trusted what they could see, hear, and feel. Allied radar ignored all of that, rendering confidence itself a liability. This growing technological asymmetry began subtly but relentlessly. Allied commanders could orchestrate ambushes, direct fighters, and reroute fleets based on real-time data. Japanese units, operating under the assumption of concealment, often walked unknowingly into these traps. In the coming months, the results would be stark. A single detection, made in the midst of storm, would surprise technicians, astonish commanders, and change the course of engagements in ways that human skill alone could never achieve. It was a turning point that hinged not on courage or numbers, but on the invisible, the pulse of radar slicing through the chaos, rewriting what the Japanese believed about the very nature of war at sea and in the skies above. By 1943, Japan's Pacific holdings were extensive but fragile. The vast distances between islands, coupled with limited industrial output, meant that defensive networks were stretched thin. Japanese forces relied heavily on visual observation posts, radio relays, and experienced technicians to monitor enemy activity. The open ocean and frequent storms were considered natural allies, masking movements from prying eyes. A typhoon or torrential rain, in the minds of the technicians, was as much a shield as any battleship or aircraft. Coastal stations perched atop cliffs or hidden in dense jungles were staffed around the clock. Technicians climbed towers through lashing rain, adjusted crude radar sets or optical instruments, and meticulously recorded incoming data. Their work was painstaking but routine. Standard operating procedure emphasized observation, signal triangulation, and reporting up the chain of command. Each squall or cloud bank was a challenge to overcome, not a threat. In storm conditions, they felt invulnerable. After all, how could anyone see through sheets of rain and blacked-out skies? Meanwhile, Japanese commanders had adapted tactics to exploit these perceived advantages. Aircraft flew at low altitudes beneath cloud cover. Convoys hugged coastlines, taking indirect routes to avoid Allied reconnaissance. Night raids were planned, assuming the Allies could not detect ships or aircraft beyond visual range. Experience had reinforced confidence. Time and again, storms had concealed movement successfully. Intelligence reports suggested limited Allied reach in adverse weather, a belief reinforced by prior operations where surprise had been achieved. Yet beneath this confidence, cracks were forming. Allied radar technology had advanced rapidly. Stations scattered across the Pacific could track aircraft and ships hundreds of miles away, even through storm clouds. Operators learned to interpret erratic blips, distinguishing enemy vessels from rain, waves, and debris. The Americans were no longer blind in storms. Each pulse of the radar sent invisible waves through the tempest, probing the ocean, bouncing off steel hulls and wings. It was a new kind of vision, one that human eyes could not hope to match. The stage was set for collision between old and new. Japanese technicians, relying on experience and the camouflage of storms, were about to encounter a force beyond their comprehension. Their instruments, meticulous calculations, and hours of observation could not prepare them for what radar could reveal. Every storm, once an ally, became a window through which the Allies could watch, anticipate, and strike. The tension between expectation and reality was reaching a critical point. The upcoming encounters would test not just strategy or courage, but the fundamental assumptions of warfare in the Pacific. And in the eye of the storm, Japanese technicians were about to discover that invisibility was an illusion, one that Allied radar had begun to shatter. For the Japanese technicians, the night was a world of routine and precision. Years of training, endless drills, and meticulous calculations had instilled confidence. Storms were obstacles to overcome, not threats. Their eyes scanned the horizon, their hands adjusted instruments, and their minds ran through checklists they had memorized. Yet, despite every precaution, an unseen force had begun to watch them. When the first reports of unexpected radar contacts reached Japanese command, disbelief rippled through the ranks. Technicians argued over the accuracy of the readings, blaming interference, static, or malfunctioning equipment. But each anomaly was real. A pulse from an Allied station slicing through rain and clouds, revealing their presence. The realization was subtle at first, then unmistakable. The Allies could see them. Confidence became tension, routine became fear, and pride and skill collided with a technological truth they could not immediately comprehend. On the tactical level, radar transformed the battlefield. Allied commanders could now anticipate Japanese movements with unprecedented clarity. Convoys that had once moved unseen were tracked across hundreds of miles. Aircraft sorties intended to surprise bases or fleets were intercepted before they reached their targets. Radar allowed for coordinated responses, directing fighters and anti-aircraft fire with precision. Nighttime became less of a sanctuary. Storms, once considered natural shields, offered no immunity. Tactical planning shifted from reaction to anticipation. Each pulse of the radar system became a tool of control, converting uncertainty into actionable intelligence. Battles that had previously relied on luck and timing were now dictated by real-time observation. Radar itself was a marvel of physics and engineering. By sending out pulses of electromagnetic energy and interpreting the returning echoes, operators could determine the position, speed, and direction of enemy craft. Early systems were fragile, temperamental, and vulnerable to weather, yet Allied engineers had refined their use in the Pacific. Operators learned to filter out interference from rain, clouds, and the ocean itself. Antenna arrays were positioned atop ridges or mounted on ships to maximize coverage. Software did not exist, but human interpretation of screen blips became a skill akin to reading a map in 3 dimensions. The technology did not simply supplement human observation. It surpassed it, revealing patterns and movements that eyes, binoculars, and intuition could not. The combination of tactical application and technological precision created an almost invisible hand guiding battles. The human element remained critical, but it was now informed and amplified by an unseen, relentless observer. The human shock, tactical transformation, and technological breakthrough converge, setting the stage for leadership decisions, enemy reactions, and the moral implications that will follow. For Allied commanders, radar offered a new lens through which to view the battlefield. Decisions that once relied on estimates, intuition, and luck could now be grounded in near real-time data. Fleet movements could be coordinated with precision, air cover directed to intercept approaching enemy aircraft, and ambushes planned long before an enemy sighting. Admirals and colonels learned to trust the unseen signals, even when storms made visual confirmation impossible. Confidence in radar-informed decisions grew as successful interceptions accumulated, reinforcing the belief that technology could extend the reach of command. Leaders on the Japanese side, however, faced the opposite reality. Reports of enemy awareness in conditions previously thought safe sowed confusion and doubt. Command structures strained under the weight of uncertainty, forcing rapid adaptations that were often reactive rather than proactive. The invisible hand of radar had begun to dictate not just battlefield outcomes, but strategic thinking itself. The Japanese military, conditioned to rely on stealth, human observation, and traditional reconnaissance struggled to comprehend this unseen adversary. Coastal stations and field outposts, once confident in their ability to detect approaching forces, found themselves exposed. Convoys believed to be hidden under cloud cover, and storms were suddenly tracked and intercepted. Technicians and officers alike faced a cognitive dissonance. The storm, which had always been a protective ally, now revealed their every movement to the Allies. The realization was both tactical and psychological. Defensive measures that had worked for years were rendered insufficient. The enemy they had relied on, the vastness of the Pacific and the chaos of weather, was no longer reliable. Radar did not merely observe. It anticipated, revealing vulnerabilities that had never been apparent. The human mind, when confronted with the invisible, reacts in complex ways. For Japanese technicians, initial disbelief quickly gave way to anxiety, then resignation. Hours spent monitoring their instruments, once routine and controlled, became exercises in uncertainty. Pride in skill and knowledge collided with the realization that an unseen technology had surpassed them. Allied operators experienced a different psychological effect. Confidence, bolstered by successful detections, transformed into a quiet sense of dominance. Every stormy night was an opportunity to assert control over chaos. The moral weight of warfare shifted subtly. Those who embraced technological advantage gained not only tactical superiority, but psychological leverage. This convergence of human, tactical, technological, leadership, and psychological factors highlights the profound implications of radar in the Pacific theater. What was once unseen, unknown, or assumed safe was now visible, trackable, and exploitable. The stage was set for a decisive turning point, where the collision of expectation and reality would reshape the conduct of war itself. March 1944. A dense storm envelopes the waters off Bougainville in the Solomon Islands. Rain lashes the jungle, obscuring the horizon, while winds bend palm trees into submission. At a remote Japanese observation post, technicians huddle under canvas shelters, peering through binoculars, adjusting antennas, scribbling hurried reports. Every sense is engaged, every sound, shadow, and signal analyzed, yet the storm offers them false security. Far across the sea, Allied radar operators watch a faint but unmistakable signature flicker across their screens. At first, it appears as a mere anomaly, a glitch caused by rain or waves. But the blips persist, moving with deliberate intent, patterns emerging through the chaos of the storm. Trained eyes decode the pulses, translating them into real-time positions of Japanese ships and aircraft. Each sweep of the radar confirms the impossible. The enemy is visible through the tempest, every movement, every approach, charted with precision. The technicians below remain unaware. They adjust dials, whisper among themselves, confident that weather shields them. Yet with every radar pulse, the Allies anticipate their maneuvers. Orders are relayed to destroyers and fighter squadrons positioned miles away, directing them toward interception points that the Japanese cannot see coming. The storm, once their greatest ally, has become a conduit for their exposure. As the night deepens, the first aircraft of the Japanese strike force emerges from the clouds. They expect to surprise their target, relying on darkness and storm. But radar operators guide American fighters to precise intercept courses. Within minutes, Japanese pilots encounter anti-aircraft fire and interceptors. Response is coordinated not by sight, but by unseen signals. Technicians on the ground watch their instruments, noting oddities they cannot interpret, unaware that the storm has betrayed them. This was a moment that would redefine engagement tactics in the Pacific. The storm, assumed to be a natural barrier, revealed itself as an arena where technology dominated human expectation. Allied commanders now possessed the power to see through chaos, to act before the enemy could react, and to turn every squall and nightfall into a calculated advantage. For the Japanese, the realization of this invisible oversight would be gradual, yet it was inevitable. That night, in the midst of wind, rain, and darkness, the first true test of radar's potential unfolded, a silent, technological ambush that human skill alone could not anticipate. The storm showed no mercy. Waves towered over the hulls of Japanese ships as radar-directed American fighters closed in. Each aircraft that had slipped unseen through cloud and rain was now illuminated on Allied screens, their speed, altitude, and trajectory precisely tracked. In the air, Japanese pilots sensed something was wrong. Anti-aircraft fire erupted seemingly from nowhere, flak tracing their paths with uncanny accuracy. The storm that had once masked their advance became a medium for their exposure. On the Japanese coastal station, technicians frantically interpreted their instruments. Readings flickered erratically, reports conflicted, and certainty dissolved into confusion. Radio warnings were transmitted too late, and even then, the information was fragmented. Ships altered course, attempting evasive maneuvers, but each change had already been anticipated by Allied commanders. Radar operators adjusted intercept vectors in real time, guiding fighters through lightning and sheets of rain to strike targets with surgical precision. Within an hour, the first Japanese aircraft were downed. Convoys that had counted on cloud cover were intercepted before reaching strategic positions. Losses were immediate and stark. Hundreds of tons of equipment, ammunition, and supplies were rendered vulnerable. Allied pilots, guided by radar blips rather than visual cues, moved through the storm as though it were clear skies. What had once been a gamble, sending forces into a typhoon or dense rain, had become a calculated engagement. The psychological impact was profound. Japanese technicians, realizing the Allies could detect them despite the tempest, were stunned. Confidence in traditional observation methods eroded. Commanders began to understand that storms, darkness, and distance no longer guaranteed concealment. Across the Pacific, similar engagements replayed this pattern. Radar-enabled interceptions, unanticipated losses, and the silent reassertion of technological dominance. By dawn, the battlefield had shifted. Japanese forces regrouped, reassessing routes, adjusting tactics, and acknowledging the reach of a force that could see through nature itself. For Allied forces, the operation validated months of radar development, training, and coordination. The storm, once a chaotic threat, had been turned into an instrument of strategic advantage. This decisive moment, where human expectation collided with the unseen precision of radar, marked a turning point in the Pacific theater. The Japanese technicians' stunned reaction symbolized a larger truth. In the war of the future, technology would no longer be an auxiliary, but a defining element of victory and survival. By mid-March 1944, reports began filtering through Japanese command. The losses at Bougainville were significant. Multiple aircraft destroyed before reaching their objectives, convoys disrupted, and vital supplies delayed. Ships that had sailed confidently under storm cover were intercepted, damaged, or sunk. Casualties mounted, not from the fury of the storm itself, but from the invisible hand guiding Allied attacks. Japanese technicians faced a grim realization. Their instruments, calculations, and experience had been rendered partially obsolete by a force they could not see. Confidence gave way to confusion. Officers debated the accuracy of reports, struggling to reconcile losses with the assumption that storms provided safety. For the first time, the illusion of invulnerability in bad weather was shattered. Allied forces, conversely, recorded a sense of quiet triumph. Radar operators meticulously logged every detection, every interception, every movement observed through the tempest. Fighter squadrons returned with reports of precise hits. Escorted convoys reached ports safely, and naval commanders updated tactical maps in real time. The storm, once a complicating factor, had become an ally. Technology amplified human judgment, allowing fewer personnel to achieve outcomes that had previously required massed reconnaissance and luck. This engagement also highlighted systemic weaknesses in Japanese operations. Dependence on visual spotting and radio relays, combined with limited radar coverage, meant that surprise attacks were increasingly risky. The Pacific's vast distances had once protected them, but now each storm, each nightfall, was a potential vector for detection. The losses were immediate, measurable, and verifiable. Aircraft downed, ships damaged, and personnel casualties recorded in operational logs. The psychological blow was as tangible as the material one. Technicians and commanders alike recognized that their previous strategies could no longer guarantee safety. Storms no longer offered concealment. Darkness no longer offered immunity. The Allies had transformed the unpredictable environment into a domain of precision, rewriting the operational landscape. The stage was set for broader strategic adjustments, both immediate and long-term. Japanese forces would need to rethink convoy routes, aircraft sortie timing, and coastal observation practices. The Allies had proven that technology, when combined with disciplined coordination, could overcome the natural obstacles that had long favored their adversaries. In the weeks following the Bougainville engagement, the impact of radar detection rippled across the Pacific theater. Japanese planners, once confident in storms and darkness as protective barriers, now confronted a reality that demanded rapid adaptation. Convoys were rerouted, night operations scrutinized, and coastal observation methods reconsidered. Yet the fundamental technological gap could not be closed quickly. Allied radar remained superior, its operators trained to exploit every pulse and reflection. Strategically, the Allies gained a tangible edge. Commanders could anticipate Japanese fleet movements, plan air cover for vulnerable convoys, and orchestrate ambushes with unprecedented precision. The integration of radar intelligence into operational planning marked a paradigm shift. Battles were no longer purely a contest of numbers or bravery. They had become a test of detection, timing, and technological leverage. Reports from carrier groups and destroyer squadrons highlighted the value of radar. Ships avoided ambushes, fighters intercepted aircraft before attacks could materialize, and losses were mitigated despite stormy conditions. For the Japanese, the implications were severe. Their reliance on visual observation and experience-based prediction had been undermined. Losses at Bougainville were the first visible manifestation, but similar events occurred elsewhere, eroding confidence across multiple islands. Technicians and officers faced a dual challenge: maintain operational effectiveness while grappling with a technology that outpaced their training and assumptions. Morale wavered, as the certainty of past success gave way to a pervasive unease. Intelligence operations evolved in response. The Allies refined radar networks, coordinated with code-breaking efforts, and expanded coverage to encompass more remote outposts. Japanese attempts to counteract radar through evasive routing, radio silence, or deceptive movements were met with limited success. The combination of signal intelligence, aerial patrols, and radar-created situational awareness ensured that many Japanese maneuvers were detected before they could pose a significant threat. The psychological impact endured beyond immediate battles. Technicians and officers internalized the lesson. The environment itself could no longer be trusted. Storms, nightfall, and distance were no longer natural allies. Each became a stage for detection and interception. Operational planning shifted from relying on concealment to seeking ways to mitigate the consequences of being observed. By mid-1944, radar had proven its strategic value repeatedly. It reshaped engagements, informed decisions, and forced the Japanese military to confront a harsh truth. The war was no longer fought solely by human skill or intuition. Technology had assumed a decisive role, transforming both the tactics and the psychology of warfare across the Pacific. The events at Bougainville and across the Pacific illustrate a profound truth about modern warfare. Visibility and knowledge are as decisive as firepower. A storm, once considered a shield, became a lens. Human skill, honed over years of training and observation, met a force beyond comprehension: the relentless precision of radar. For Japanese technicians, the shock was immediate. For Allied operators, it was confirmation of vision and foresight. But beyond human reaction lies the deeper lesson. War is not only fought with courage, numbers, or strategy, but with understanding the unseen. Radar transformed the invisible into actionable knowledge, turning chaos into advantage and uncertainty into control. The technological shift was not merely tactical, it was philosophical. It challenged assumptions about concealment, trust and experience, and the limits of human perception. A storm, a nightfall, or a cloud bank could no longer guarantee safety. Warfare had entered a new era, one where machines extended human senses and decisions reached farther than ever before. Yet the story is also a human one. Technicians staring at blinking screens, pilots navigating torrents of rain, commanders weighing decisions informed by pulses of unseen energy, all reveal the intimate intersection of human courage and technological power. It is a reminder that history is shaped not only by what is seen, but by what is revealed when humans learn to see beyond the obvious. In the end, the Pacific storms remained indifferent, as they always had. But the war beneath them had changed. Invisible pulses, meticulous observation, and technological insight had redefined the battlefield. And in that quiet, relentless transformation, the contours of modern warfare were forever altered.